Hi guys, this video is about the video Dave Weiss did with Dave, so-called Professor Dave. So we've got flat earth versus the globe, right? So I thought I'd do a quick video on it, but basically just going over the same old stuff I'm doing all the time. They just don't get it. Science knows nothing about this tropical gap. They don't even know what the tropical gap is on our flat earth. They just tell you live on a spinning ball and tell you the magnetic field flows from the south up to the north of the ball. They don't know how magnets work. They tell people that science and all the BS you've learned at school has got nothing to do with reality, how a magnet works. They don't tell you about this field here that goes like this. They don't tell you what the tropical gap is for, even though we've got induction motors, magnetic induction motors with a gap between the fields. No, they just want you to think you live on a spinning ball. So Dave's first question is, how do we, on a pancake, see two rotating skies? It was quite easy. That rotating sky on the north is a parabolic image of the rotating sky on the south. We're not looking at one individually, we're looking at both of them. I can look with a telescope and see two skies. I can see the northern horizon moving like this and see the big southern horizon over my head going like this. You can't have two rotations on one ball with a gap like this. Okay? It's the best time to look at it when you're dead straight across the meridian, north to south. So you can't even debate with people like Dave because he doesn't know enough to debate, you know, in regards to the magnetic fields. They're just brain dead. They just know nothing about it. So it's pretty hard to debate something of reality with someone who has no idea, and because he's so brainwashed and filled up with that science nonsense he learnt at school, you can't get a grasp on it. But this is basically what's happening. You're getting a rotation there, and there's a rotation out here. And you're continuously getting an image, a rotation, anywhere around the earth. That's the second question. How do we all see up in the south the same northern image? Because it's all from the centre here cast out. That's always turning, and this is always turning with it. But at the same time, as this turns, it's just pulling this field around like this, but there's still an image back here, because that hasn't disappeared, that hasn't moved away, it's still there, it's always turning. There's always an image, but you've got to realise this is turning, so this will be turning all the way around like that too. So forever there's an image here turning. So in reality, that image he sees isn't exactly the same as this guy's here, because this has revolved that little bit more from here. It's revolved, that star that was there is now around here, so it'll be seen out here. And the third thing is about stars. Why do you not, you'll see a star in the north but not in the south? You'll see it in the north and the south if you're on the right meridian. If you're on that meridian, right there between those two curves like that, you start looking off on an angle like this, it starts getting warped. You have to wait till, you know, you're in this position here, or stand in that position, dead north to south. And then there's another question is, you're in the north, you see Polaris, you're in the south, you see Sigma Octantis. How come you can't see Polaris from the south? Well, you can, because Polaris is Sigma Octantis. Sigma Octantis and Polaris are the same. It's fainter out here because it's a bigger, weaker field. It's more broad. Look, it's stretched out. The energy around here is the same energy in that sharp choke point. So that makes that the strong energy. The strong force and the weak force. So you get a parabolic reflection. You've got a rotation out here. And what's the centre? Sigma Octantis. Centre, that's Polaris. They'll always be there forever and a day, because they're actually another image of their sun, but that's beyond most people. They can't get their head around that one, because it's right above the Arctic centre, dead centre, or slightly off centre, because the sun is off centre of the black hole. The black hole is the dead centre. You know, science knows there, it's all off centre. Go look into it. off-centre, does a little rotation around that centre hole. And that's what the sun does. Check out all my videos. But anyway, we'll run through the video, eh?
What's the three-body problem? I'm sure you know about that.
Oh, the three-body problem, so we can't do calculations.
Stop being such a condescending prick. We already know. Just talk normal. Have a discussion.
Sorry, hang on 1 second. This is serious. This private chat keeps covering
Whinging
this.
Dave.
This stop.
Whinging Dave.
Some stuff.
Well, here's the thing. I would like to get off of the lights in the sky because I'd rather talk about the shape of the Earth.
Just destroy the flat Earth.
Well, you say that, but the lights in the sky have nothing to do with the flat Earth.
Okay, so this was my first talking point. Were we going to do the talking points that we prepared? Because my first talking point is about this, and it is an absolute annihilation of flat Earth. That's why you don't want to talk about it.
Let's address that. The sky has nothing to do with the flat Earth. Yes and no. It doesn't really, because Earth is fixed and stationary. First, Earth is the plane of inertia between a positive field and a negative field. They rush to a point, bang, there's your plane of inertia. The resting point. This is what you'd have if you lived on a spinning ball in the field from the south, went to the north. It'd be it. It'd be all over, fixed and stationary, dead, no life, no nothing, because that's the plane there, right there. It's found equilibrium, bang, no life. So that's how you have to see Earth. But you've got the magnetic field around it. So then you've got to move on from that, because that's Earth itself, fixed and stationary between the two fields, like the 0 point type thing. But you've got the field flowing, the magnetic field flowing like this. So you can look at it as an atom too, a magnet or an atom. A ring magnet or an atom, because it's the same thing. It all comes out of here, the energy, the field, the strong forces in here, and the weak force, it's all north. Well, there's the equator, tropical gap. So the weak force is from there, the strong force is from there to there. It's the northern horizon. There's the southern. You had the tropical gap. Because of the tropical gap, the two forces aren't meeting. They don't meet. They come over here, go, and they go shoot and through the ground, and then come up here, and they go along and down and through the. These never connect. If you close that gap up, that would be it. The end of your magnetic field. But if you just check out all my other videos. So, there's your flat Earth. This has nothing to do with the fixed and stationary Earth, does it? That's the moving toroidal field, magnetic field. And what's in here, all the stars and everything, aren't going to fit down here, are they? You bring all those down, they're not going to fit here. But it does if you understand that curving magnetic fields, they'll all start fitting in. If these distances here all fit in if the field's curving. And that's how it works on the flat Earth. Because the magnetic fields aren't straight, they're all curved. It's what you call the run lines. All sorts of names. But in this model here, man has his own arc of horizon. He sees that far and he'll see all this. It's a beautiful, nice, symmetrical 180-degree arc. And everything comes back to him. All light is all perpendicular to that arc. 90 degrees to that arc. So because it's such a short distance, science tells you, oh, it's coming in parallel. And they don't try to tell you you look out here. Oh, look, light's coming in parallel. No, we're down inside here, mate, and all the light's coming to us, to man. We all have our own arc of horizon. You can't have a person here and see this image here. This image will be like this. Here's his arc, See, science, they know nothing about this sort of thing. They should just start again. They have to understand magnetism for a start, and they don't.
That's why you say, why do we look at the things in the sky to figure out the shape of the earth? Because that's how we figured it out 2,000 years ago, by looking at the stars.
Yeah, I've got a book they claim is only 1,200 years old. It's much older though. It's got the whole flat earth right down to the finest detail. Right down to electrical, magnetic fields, scalar waves, helix, flat earth model. Exactly what I've been doing, showing people over 2 years. And they're trying to tell you, oh, we've known for 2,000 years, that's a very important.
Okay, so if you're in the northern hemisphere looking at the North Pole, then hang on, all this stuff is covering.
You're looking at Polaris, dead center.
Anyway, if you're looking at the North Pole in the northern hemisphere, the stars rotate counterclockwise. Go to the next one. If you were in the southern hemisphere looking at the South Pole, the stars rotate clockwise. Next one. How does this make sense on a flat earth? Sorry, this is a screenshot from one of my videos. So in the video, they're rotating in different directions.
By having a mirror
Two
image
people on a flat pizza land look at the sky and see a sky that is rotating in different ways. Next one. And further.
Anybody can go outside, look at the celestial equator. There's the celestial tropical gap, and see 2 rotations. Now if you use your camera, star trails, you'll see the gap. You'll see the gap. Like this. Aim dead north and south. Watch this gap. Best time to do it is follow Orion's belt, because that's right centre. Flowing through. It's gone now, it's gone over the horizon. We have to wait 3 months now, because it travels all the way around here. So does the sun and everything. These are all projections, remember? So does the sun. But the sun's quicker and catches up to it. And buries it for 3 months. Then it comes out, but they're all moving around here all the time. Stars are, you just concentrate on that one image in there, because this is just a reflection, a mirror image from what's in here, plus you're getting the Milky Way out here. But it's all in there.
Or why can't we all see the same stars? There are stars that you can only see in the northern way towards the northern.
Why can't we see all the same stars? Well, we do. If you're looking on this meridian, north to south, otherwise they're slightly warped. This star will be over here, this, which will be, it's right there, it'll be back here. So the northern stars are the southern stars, because the Milky Way is the core in the centre of this star picture. It's inside, you've got all the background stars, you've got the core of the Milky Way stars. So you've got this overlay going on.
And stars you can only see in the southern hemisphere. Next one. On a globe, this makes perfect sense. If you're in the northern hemisphere looking at the North Pole, east is to your right. If you were in the southern hemisphere looking at the South Pole, east is to your left. Next.
Doesn't make sense. When you look at the celestial equator and see 2 rotations with no reference to the ground, and you're seeing 2 skies, 2 different rotations. Hang on, shouldn't the sky just be going like that? No, there's one this way and there's one that way. There's 2. And east is always this way, west is always this way. It's always right angles to the centre north, isn't it? North, south, there's always a south here, because it's the opposite to north. Like that, like that. So if you're going to draw a line from north to south, you've got to go this way if you're going east or west.
And the reason we can't see certain stars is because you can't see through the Earth. Next one.
You can't see certain stars because you can't see through the earth. You know, no, he's like a 5-year-old. Like I just said, the sun catches up. The sun will catch up and bury the stars. So if there's a star here and the sun comes around and catches up to it, what's going to happen? It's going to cover it. You're not going to see it anymore because it's going to be stuck in daylight hours. Then then the sun is finally going to move off it, and then you'll see the star. But as the sun catches up to a star and buries it, so these are all your stars, sun's racing along, let's say it's here, you've got all these stars coming in behind at night time, right? Well, the sun, let's say the sun races up there and buries this one, all the stars around here, then obviously these ones here are going to turn up again in the night time, aren't they? But the sun's going to chew up these stars in front as it's racing over them. Then they're all going to pop out the back here as he moves off them. Around the earth like this. It's all spinning out of the centre, remember? All the way back in there. So, you know, they don't even know that. They don't even know the sun moves quicker than the stars. They don't even know the sun is on the horizon of the black hole. They know nothing.
That's why in the northern hemisphere we can't see the Southern Cross. That's why in the southern hemisphere we can't see Polaris. Next one. Almost done.
Yes, you can. There's Polaris. Sigma Octantis is Polaris. They even called it Polaris Australis. I wonder why. That's called Polaris. Polaris Australis. The other Polaris. They just, you probably mostly know it as Sigma Octantis, but it's the same. You can't see both from the equator though. It would be a bit weird seeing two at the same time. No, right in that tropical gap, the equator, you cannot see either. Or you have to come off to see one of them. This proves the gap between the two rotations.
Quick one here. So it actually gets a lot worse than that in the southern hemisphere because you've taken a globe and you've unwrapped it.
I
The
need
southern
to really
hemisphere
dumb.
makes absolutely no sense. People in the southern hemisphere who are all looking at the Southern Cross are somehow supposed to be, we're believing that they're all looking in completely different directions and seeing the same object often at the same time. Next one.
See how thick they are? They can't picture this. They can't picture an image. They can't picture the fact there's an image in here, shot out here, seen out here, or image here, around further, out here, all out south, all protected from the centre. That's beyond them. They can't think. These people are running your world.
Because Ash is doing this. Oh, has it done it? Is it worked?
Yeah, that's it. I think this is the last one. So again, on a globe, south actually means something. People who are looking south are all looking at the South Pole. They're all looking in the same direction, so that's why they all see the same thing, such as an object like the Southern Cross.
All right, can you go
I
back
think that's the last one.
Let me go through the
Just
slide.
check if it's the next one.
Yeah.
Now, if you haven't seen any of my earlier videos, the ball doesn't curve around to it doesn't reduce to a ball around, return back under. You know, due to the fact that science tells you that. No. We're in a toroidal field. And the toroidal field is always forever moving around the fixed and stationary flat earth. So the field gets bigger out south. It comes out from the centre, look how tight it is, comes out, flows out. They're getting bigger. So the field's getting quicker because we're all in that field. So you could say we're expanding. We expand with the field. Earth doesn't move, it's fixed and stationary. Fixed earth will always be there. But us in the field will get there quicker. You're coming out of the north and you're getting bigger. That's how it works. That's way beyond these silly, simple globers.
Check if it's the last one.
And if you go back to the first one, that would be great. So, in your world, with people standing upside down and you're assuming hemispheres on a sphere.
What do you mean upside down? What do you mean upside down? What does that mean?
Compared, their feet are antipodal to my feet, people in the south.
Okay, so yours are upside down compared to them. What's the difference? What's down on a globe?
I'm not saying, I'm just saying people are upside down to each other halfway across the world. So, if we can go back to the original slide so I can remember all the points he made so I can address them, that would be fantastic.
I think the issue.
So, you know, just imagine that. What's down on a globe? Well, they created that model. You know, they said there's no down. Yet we know there's up and down here on Earth. but there's no up or down out there in La La Land, in their make-believe world. Yet they come up with gravity and say, oh, all the water's, everything falls back to earth. Water flows down mountains, they say that's gravity, but it stops at sea level and doesn't run off the bottom of the ball. So gravity is selective. It'll only come down the mountain to the lake, but it won't run off down the...
Oh, I don't know.
No point in hanging out listening to all that, but I've gone over his points. Go check that video out. And, if you're going to debate a glober, you've got to know your magnetism. You've got to understand what Ken Wheeler's been talking about. But even Ken Wheeler and them, they don't know of the tropical gap. They don't know of the gap in the magnetic field. So you need to watch my videos to understand what's happening. Because the magnetic field comes up from the south and curves up like this. But due to the fact, a toroidal field, you need to understand how that works too, because you've got the Coriolis effect of this curving, but then it's the same curving, but as it's going down, they then go and call it the Eopphos effect, or Eopphos, down. This is the Coriolis curving of the field like this, but it's going over and curving going down. This is science for you. It just keep making up names for everything, but it's the same thing. It's just the magnetic field of the toroidal field. It's what they're calling even dark energy, the cosmological constant. It's all the same thing. It's all part of the toroidal field. And the toroidal field, it curves like this, and it goes down through there, the Tropic of Cancer, Capricorn, then shoots straight down, goes through the earth, off the earth, then back up here, around here. Then over the top, comes to Cancer, goes straight down through the earth and back up out south here somewhere. You get this thing going on like this. You have to check out earlier videos. But all this action here, there's heaps of them all around here. It's just a magnetic field. So they've gone and given it two names, Coriolis and Eopphos. Check out that. That's a joke. This curving down here is out south, and it will curve back down on that way as it goes down. Swings up and around and down like that. Get yourself a little Taurus toy. So to debate these flippin' idiots, you need to understand all this. If you haven't learnt the real stuff, you lose a debate. So you've got to understand how a ring magnet works. You have to check out earlier videos how they work, because even Ken hasn't got it right. He's got the main stuff there, but nobody's spoken about this here. Only Nigel Cheese and I have talked about this gap here. You need this gap. And how there's not two fields, there's four fields if you want to talk about north and south poles. But at the end of the day, it's strong force versus weak force. And it's the strong always seeking the weak, and the weak always seeking the strong. But they can't do it above Earth because of this tropical gap. But Earth has, and that's what's fixed and stationary. It's reached equilibrium, 0 point, bang, fixed and stationary, no action, not going anywhere. That's Earth. But the fields around it is flowing, and that's what creates life on Earth. If it stopped flowing, we'd be dead.